Okay, so I guess let's start. Hi everyone. For those of you that have never met me, my name is Bill Laboon. I'm the technical education lead here at the Web3 Foundation. Just so everyone knows, this is going to be recorded. Well, it is being recorded as we speak, or as I speak. We will have this online, so if anyone wants to review it later, feel free to do that. And I'll ask you, if you don't mind, if you don't have a question, you can please mute your speaker so we don't get any feedback, or your microphone. And I'll have a section for questions at the end, but if you, excuse me, aren't sure what's happening or have a direct question about what's going on, please feel free to just send a chat message or raise your hand, and I will see about answering that. All right, so yeah, so just a reminder, please keep your microphones on mute, because otherwise I can hear feedback. Okay, so let me share my screen here. Hopefully everyone is seeing this. Okay. So if you're here, hopefully you are here for the talk on Kusama. So what I would like to discuss today is basically what is Kusama, what's the point of it, and some of how it operates. What we anticipate with Kusama is that it is going to be very, very similar to how the Polkadot mainnet operates. However, because it is a Canary network, because it is an early release, we are also hoping to learn from Kusama and learn how things work, what goes right, what goes wrong. And so there is a chance that anything we discuss in terms of Kusama may not hold for Polkadot mainnet, since we are using Kusama as an educational opportunity. So also just a little bit about the Web3 Foundation. So our goal is to develop a fully decentralized web. We want to bring more trust in, reduce the trust that we need in others and in large systems, allow users of the web to resist arbitrary authority, and basically allow us to take back what the web and what the internet used to be. If you're interested in more details about the Web3 Foundation, you can go to www.web3.foundation. So one of the ways that we plan to reach some of the goals, how we see the future of the web at Web3, is using blockchain technology. And the reason for that is because blockchain really lines up with a lot of what we are trying to do. So if you are the type of person to be listening in on this call, then you're probably well aware of what blockchain is and why we might want to use it. But I just wanted to very, very briefly go over why we see this as sort of the way forward. We see decentralization as very important, not having control of the network or of an application in the hands of a single person or entity. Transparent, people can see what is happening on the network. It's extremely robust. We don't want a single point of failure for the system. It allows you to act pseudonymously, or in some situations, like with some of our parachains, actually anonymously. We don't need trust in any specific system. It should be very easy for anyone to prove that whatever code is being executed is what's being executed. And finally, it's auditable. So you can actually look back and see what happened and make sure that there were no problems. So again, if you're interested in blockchain technology, none of this should really come as a surprise. Then the question becomes, all right, well, there are a lot of different blockchain technologies out there. So why Polkadot? So Polkadot and by extension Kusama is aiming to really be a foundation for other protocols. As Gav Wood put it, it's sort of a bet against blockchain maximalism, that there are a lot of specific blockchain maximalism, because there are a lot of different kinds of blockchains and a lot of different trade-offs that you can make when developing a blockchain. We'll actually talk about some of those trade-offs and why Kusama made them in one direction or another as we go along with the talk. But different blockchains will have different uses. So Polkadot aims to be a foundation for these other protocols and also allows them to be interoperable with each other. So you'll be able to send messages and interact from one blockchain to another. They can actually pool security. So one problem that you have with like traditional proof of work systems is what's called the infanticide problem, is that when you first start up a blockchain, if you don't have a lot of people on it, it can be very easy to have someone take over that blockchain. But by pooling security, we can really mitigate that risks. We can allow heterogeneous chains to interact with each other. That is, if you have a chain that perhaps has much faster block time or uses a different kind of scripting language or uses Plasma or any other kind of particular trade-offs you may have made, then you will actually be able to interact with other chains that may have different trade-offs that they made and have different capabilities that you may need or want to interact with. And finally, Polkadot has really well thought through governance. So we have several researchers who work on governance. We haven't just thrown things against the wall to make sure that it sticks. We have a system, and we'll discuss governance in Kusama in depth a little bit more later on in this talk. But it really has been thought through, and there are a lot of papers, and I am happy to point people towards them, that show how our system and our system of governance can work well and can allow the system to actually progress via through the needs of the token holders, and actually allow people that are holding the token to vote on the future direction of Polkadot. So there are already a lot of different things being built on Polkadot, even though mainnet has not been released yet. So we have Edgeware, a smart contract chain, data curation networks that'll allow places to put data and look it up, Oracle chains to get off blockchain information onto blockchain, identity chains, financial chains that allow people to store different tokens and other financial assets on a chain, chains that focus on interactions, the Internet of Things, privacy chains that allow anonymous communication and value transfer. There was just an announcement this morning that Polkadot, there's a Polkadot app now for the Nano Ledger, Ledger Nano, that will allow you to use a hardware wallet to store Polkadot and store your dots. So there are a lot, and interact with the Polkadot blockchains. So there are a lot of different things happening on Polkadot right now. All right, so this is a talk on Kusama and not Polkadot in general. But I think it is important to understand what Polkadot is before we can really talk about Kusama. So Kusama is Polkadot's Canary, as we're calling it, Canary network. As far as I know, this word or this phrase hasn't really been used before because Kusama is kind of a unique concept. So it is not a test net. It is not. It's an early, unaudited release of Polkadot. So what we see Kusama is kind of a middle ground between a test net, which has anyone can get tokens, they're freely available, and an actual mainnet where you have like actual value being stored on chain. This is somewhere in the middle. Because everything that you could do on Polkadot, you should be able to do on Kusama. And we do anticipate that Kusama will continue and be a network that is not something that we kill or decide to end support for at some point. It is going to be in the hands of the community going forward. We're also going to use Kusama, as the reason we call it a canary network, is just like a canary in the coal mine, it allows us to see early problems with the network before mainnet is released. So as people work on Kusama and do things with Kusama, we can see what works and what doesn't, and take those lessons and bring them to the Polkadot mainnet, which should be launched later this year or early next year. All right, so why should you use it? Why not wait for Polkadot mainnet to come out? Well, Kusama is running now. The mainnet obviously is not. And this is a chance to try out Polkadot's functionality, prepare for the mainnet launch. If you were thinking of doing a project on Polkadot, doing it on Kusama, starting on Kusama is going to allow you to try out all kinds of the different aspects of its functionality before the mainnet launch and to get prepared. So just to give a timeline of where we are now and what's happening with it, in July and August of 2019, we allowed any DOT holders, so people that already owned DOTs, could claim KSM tokens, the Kusama tokens, for the Genesis block. The network opened for business on August 23rd. However, it was a deliberately reduced in functionality. So there wasn't much you could do on it besides just make claims for any Kusama tokens that you were owed and signal your intention to validate. That is to validate and produce blocks. However, it was then and currently is a proof of authority network being run by the Web3 Foundation. In the very near future, we'll be transitioning to a proof of stake system and ceding control and putting it into the hands of Kusama token holders. So this should be happening very soon, probably early October 2019. During this early phase, we've been shaking out some of the problems with Kusama before actually transitioning it to a proof of stake system. However, it looks like we are in the final stages of that, and so it should be going live as a fully Kusama token controlled system very, very shortly, within a week or so. So what will you be able to do with Kusama? So as I mentioned, at the moment, right now, really all you can do is signal that you want to be a validator or claim your Kusama tokens. However, anything you can do with Polkadot is theoretically possible with Kusama. So you can participate in governance, that is, you can vote on things, and we'll talk about how governance works a little bit later on in this talk. You can run for council, so you could try to become a member of the Polkadot Council, which is going to have some additional powers that we'll discuss later on. You can validate, act as a producer of blocks. You can nominate, that is, you can stake your tokens to behind different validators or yourself. You can connect parachains and communicate between them. So note that some of this functionality, especially connecting parachains and communicating between them, the ancillary tooling for this is not ready. So the core functionality is there and is theoretically possible, but the ancillary tooling to do it, the sort of the side tooling to make it easy, is in the process of being developed now. So once again, is Kusama a testnet? No. Why not? Kusama tokens are limited. So those of you that were around in the room, the Polkadot water cooler on Riot, you probably have seen somebody saying, "Hey, can I have some tokens, some Alexander test network tokens?" And I or Logan or Anson or somebody would say, "Sure, here, have some dots." However, Kusama tokens will be limited. There are a few ways to get them, but they won't just be handed out to anyone who asks. There will be a faucet, but the faucet will be frictional. That is, you will have to do some computational work in order to get Kusama tokens. The community is going to be in charge of the Kusama network. There's no kill switch. There's no turning things off. We do anticipate there will be non-test activity occurring on Kusama. Now, we think that one use of Kusama will be people testing things out and preparing for the Polkadot mainnet, but it's not going to be just test activity. We anticipate that there will be people that may not need all of the security of Polkadot mainnet who may continue working on Kusama. So that being said, Kusama is not a test net, but you should expect chaos. That is, expect that things may not work all the time, especially at the beginning. You should expect that there will be errors or issues or things that we change going forward. So that's why it's a Canary network, right? You should expect chaos. There are no promises as to the stability of Kusama. Polkadot is going to be a much more stable version. We're going to take the lessons we learned from Kusama. We're going to have a full audit of the system. Kusama is an early release of the software that we'll be using for Polkadot. So I guess before we move on, does anyone have any general questions about why Polkadot? What's the rationale for this or anything like that? All right, I will then continue. So Kusama's architecture is very similar to what the plan is for Polkadot mainnet. Basically, we're going to have a central relay chain through which parachains and other chains that will act as parachains can interact with each other and share security. That's one of the big benefits of being a parachain on Polkadot, is that you get to share security with the entire system and interact with others through that. So if you're not familiar with the basic architecture of Polkadot, again, we have a relay chain and validators which produce and finalize blocks on that relay chain. And then collators that are running on the parachains, packaging together the state transition of that chain and sending that information to the validators as they produce blocks. So there are other roles that exist, such as fishermen who can look to determine if anyone is cheating in terms of the transitions between blocks. We have nominators who can actually put their stake behind validators, since the system is backed by the value of the staked tokens. You can be a node operator and not validate, just like having a Bitcoin full node. You're just verifying all the blocks that go through. So there are other things that you can do on Kusama besides just validate and nominate. So I think this is I think that this drawing actually sums up how Polkadot works very well. So you can see we have a central relay chain. So this is just a regular blockchain that blocks are added to it by the validators. The validators also finalize the blocks, and we'll talk about what that means in a moment. And we have a variety of parachains. These are entirely their own blockchains that can scale. So when we first launch Polkadot and Kusama, we're anticipating we'll have at least 50 to 100 validators. So these validators act kind of like miners. I'll talk about the difference very shortly on the system. So we're going to have a very decentralized system of validators. And we'll be able to handle, we're going to start with a relatively small number of slots for parachains. So something like this, 8, 10, 20, something like that. But we anticipate that these can really extend outwards more and more. With technologies like Plasma, we could even have thousands of blockchains all operating at scale. It's one of the reasons Polkadot is very good for scalability, is because not everything has to happen on the relay chain. In fact, a very small amount of the work that is necessary for all of these chains to be operating and performing their state transitions has to be recorded on the relay chain. You can see here we also support bridges. So bridges are actually kind of like virtual parachains that allow you to interact with other, already existing blockchains such as Ethereum or Bitcoin. So each individual parachain, interacts via some set of validators and has its own collators. So what collators do is they basically are running the equivalent of a full node on that chain, and then verifying that all of this, the transitions, the state transitions of the blockchain meet the rules that are defined for that blockchain, that there are no invalid transactions going through, and that the block. Is that a question? Oh, thank you. Where was I? Yeah. So these collators are going to get the information from the parachain, what the state transitions were, put together a proof that it was actually meets the requirements of the parachain state transition function. Because if we think of what a blockchain is, really it is just each block is just a new transition in what the state of the chain is. So that could be something like this account had N tokens and now it has N+1 tokens, or whatever, any sort of change in state if we look at it from a very abstract level. So these collators, and there can be multiple collators per chain, then interact with the validators on the relay chain to prove what has happened on this parachain, and this proof gets added to the relay chain. So how are these validators selected? Where do they come from? Well, there is a certain set of validators. There's the active set. There are certain slots for validators for these to fit into. So there are some set N of validator slots, and basically the validators that have the most stake behind them, the top N validators, will get to go into those slots. I'm saying N slots because this is something that actually can be modified on chain. So via governance, we can modify the number of validator slots available. So if we determine, if the holders of Kusama tokens determine that having, so for example, when we start, we were going to look for between 50 and 100 validators, but we determined that, oh, it really makes much more sense to have 500. You can actually vote to modify that number via governance. So each validator is running, it's an actual server. So you are a node you are running, which has two main responsibilities: to produce and then finalize blocks. So nominators, in order to get into these validator slots, as we mentioned, you need to stake your Kusama tokens to a validator. You can do this yourself, so you can run a validator, and if you have Kusama tokens, you can put them behind that validator. Or others can actually stake their Kusama to a validator or validators and share in the rewards. Okay. Oh, did I forgot to represent? I'm sorry. Thank you. Oh, it says that I'm sharing. Can everyone see my screen? Can anyone see my screen?
Yeah, I can see it.
Oh, okay.
You just have to kind of change your view. You can see your face and you can see your screen if you open up.
Okay. All right. Glad everyone is seeing the screen now. Thank you. Okay. Whoops. Wrong. Okay. So we have these validators, which again are taking information from the collators and producing and finalizing blocks on the relay chain. They also will work with events that are occurring on the relay chain itself. So, for example, transferring Kusama tokens from one person to another on the relay chain is something that the validators will still add that to a block. It's not only what's happening on the parachains. Something to keep in mind: a single person may, or entity, whatever, can run multiple validators. So unlike in a proof of work system, if you have more computing power or more tokens behind one specific validator, that does not actually help you gain any more Kusama tokens. You don't get any more block rewards than any others. The validators in each validator slot will receive the same number of tokens as a reward per block produced. Okay? So if you do want to stake more, you'd actually have to run multiple validators and have enough to also get into the active validator set, enough stake bonded to you. So collators, as I said, they were going to run on parachains, and they're going to communicate the state transitions of those chains to the validators, or send other messages that might be going externally from that chain via the interchain messaging protocol. So we also have bridges where what happens is we have a virtual parachain. So to the relay chain, it looks like there is simply a parachain with collators. However, there is also an interface to the larger external blockchain. So some of the two chains that we're really focusing on for getting bridges for are Bitcoin and Ethereum. But there has been talk about other chains as well. But the idea is that you will not have to do a parachain in order to interact with Polkadot. And similarly, it's entirely possible, if you don't want to have the shared security of Polkadot, or don't want to pay to be a parachain, an official parachain or parathread, you can actually use the same tooling to produce a parachain and just never connect it up to the Polkadot network. So you would have your own blockchain that you may use, like for proof, a proof of authority chain, or a proof of stake chain, or proof of work chain, whatever you want, and it does not have to connect to the relay chain in order for you to have a functioning blockchain. However, you do get a lot of benefits by doing so. So the last thing I want to discuss here, and one of the things that I think is very interesting compared to other blockchains, or like these multi-blockchain foundations, is the concept of a parathread. So where a parachain, it fits into a parachain slot on the relay chain, it stays there, all state transitions or blocks are put into the relay chain. A parathread, just like a thread on a computer, is actually going to they can take turns interacting with the blockchain, with the relay chain rather. So what you may have is multiple blockchains, multiple parachains, and they don't always interact with the relay chain. They only interact with the relay chain when they have to. So for here, instead of a parachain slot that is eternally linked to linked for a very long period of time rather, for a parachain to interact with, you could have different parachains basically auctioning, running an auction to see when they're going to have a chance to put their state transitions onto the relay chain. So again, this is just like a thread on a modern computer, right? You may have thread A interact with the system, and then thread B, and then thread C, and they're all running on the same CPU. They're just taking turns. Similarly, if you didn't want to pay for, in dots for having a parachain slot, but you only wanted to either have it for a very brief amount of time, like try it out, Or you have, for example, a blockchain that has a lot of reads but not a lot of writes. It doesn't update very often. It may not make sense to have a full parachain slot. You can have a parathread, which is sort of a pay-as-you-go model. And it should be very easy to switch back and forth between being a parachain and a parathread. So you can decide that you have a lot more volume coming through, and so you want to be a parachain, or you may decide that, hey, my parachain, there's not a lot of activity on it, and so I'm going to downgrade down to a parathread. And you should be able to swap back and forth between these two things depending on which works best for your particular parachain. All right, so I want to discuss a little bit about proof of stake since I've mentioned it already. There is no mining via proof of work. So there is not, this extra usage of, hash calculations like you see in Bitcoin or Ethereum. It's secured by the economic power of the Kusama token instead of this, extra work having to be done. So if you wish to produce blocks, if you want to be a validator, you're going to need to bond enough stake to get into the top end slots. And at this point, you will be able to validate. So you are going to get every time every time you produce blocks, you're going to get an equal amount of Kusama tokens as rewards as any other validator. So our goals here in producing a proof of stake system, we want to have a nice decentralized system with a large number of validators, and hopefully a large percentage of them are honest. That's again something we try for, but in a decentralized pseudonymous system like this, you can never enforce that everyone is going to be honest. We really want to make sure that there isn't one or two validators that overwhelm the system or have a large amount of control over the production of blocks. So what we try to do is have a similar amount of stake for each validator. We actually have a variety of mechanisms that enforce that from a game theory perspective. And we also want minimal work necessary for validation. What we don't want to see is using immense amounts of electricity for wasteful calculations. So our goal is that about 50% of the Kusama tokens will be used for staking. There are obviously other uses for Kusama tokens. You could be using them to auction for parathreads or bonds for parachains, making proposals, which we'll talk about a little bit in governance. Voting is via the fragment method to allow as smooth as possible and decentralized as possible distribution of tokens amongst all of the validators. So the fragment method, we have a link to it on if you look in our wiki, the Polkadot wiki, you can look more into detail about this. But very briefly, it's basically an approval mechanism. So you say, here are you as a nominator, if you have some tokens to stake, then you can say, here are the validators that I approve of. And then it will use an algorithm to, given who all approves these different validators, what is the most equal way to share your stake amongst all of those validators in such a way as to try to make it as equal as possible amongst validators. As I've already mentioned, validators are rewarded equally. So if you have one validator and you have 500 tokens staked to you, but you're in the active validator set, or if you have another validator that has 50,000 tokens nominated to you, you will get the same rewards since you're doing basically the same thing. You're producing and finalizing blocks. So one thing, all right, 1 second, let's see a question here. Yes, is Kusama POS inflation model already defined? Yes, so it turns out that defining it specifically giving you an absolutely exact number is rather difficult, because as part of the this goal of trying to get 50% of tokens staked, there's actually some modification to how much the rewards are based on how much is staked or how much is not staked. But basically, we're looking at, we're thinking of inflation of between about 10 and 20% the first year. And I can, if there's a link on if you look on the wiki, you can see the specifics of how it would end up on one side or the other of that. Depends on what percentage of the tokens people actually use for staking versus for other things. But it's not like Bitcoin, where we have a very well-defined, or it is going to be N%. It is going to be, again, between 10 and 20%, depending upon how much people use specifically for staking and not for other things. And feel free, if you want to, email me after this. If people have questions, feel free to email me afterwards too. Bill@web3.foundation. I'm happy to answer your questions there too. So one of the things that was kind of a problem with proof of stake traditionally is what's called the nothing at stake problem. So in a traditional proof of work system like Bitcoin, if you try to produce an invalid block or make a fork, well, you've got some automatic punishment built in, because in order to produce a block, you had to do a lot of work that would be wasted if you produced an invalid block and tried to pass it off as valid. However, in a proof of stake system, since it's entirely internal to the system, there's really no waste, or very minimal waste, in producing an invalid block. And so what we need to do is punish you somehow in order to get the proof of stake system to work, and to from a game theoretical perspective, make it not worth your while when you are actually trying to produce invalid blocks. So how we do this is via slashing. That is, some of your tokens that you have staked are removed from you on the main chain. Oops. So there are a couple of different reasons for slashing, and I'll talk about what Babe and Grandpa are in a few minutes. But basically, again, there are two things that validators are doing. They're producing blocks, and then a little bit behind that, they are finalizing them, making them canonical parts of the chain. So you can have a couple of different reasons for slashing. So you can either try to produce two blocks at the same time, which is definitely, shows you were trying to cheat the system. You're trying to create multiple blocks. You only in each slot you produce a block. You're only allowed to produce one. You can sign conflicting chains, that is, try to finalize two different chains. It's called grandpa equivocation. Or you could just be unresponsive. So as a validator, your job is to be online a very high percentage of the time. A very large number of nines, if you will. So if you fail to send the heartbeat message, it's called the I'm online message, you can get slashed. However, this only occurs if there are multiple. If we have a single incident, if you lose connectivity for a minute or something, and don't send one of these, that single incident is not slashed. It's only if there seems to be there's a large number of these validators are not responding, which could indicate a coordinated attack, or at least poor decentralization, everybody running a validator on the same data center or something like that, or if you're offline for a long period of time. So if a validator gets reported for any of these offenses, that validator is removed from the validator set, a new era starts, and they are slashed. The slashing is, here is the algorithms we use for how much is slashed. So it's a minimum of 1% for an equivocation, or 0.05 for unresponsiveness. So it's not, unresponsiveness is not meant to be a it's been meant to be more of a slap on the wrist than equivocation. Equivocation, actually signing multiple incorrect or conflicting chains or producing multiple blocks, is much more indicative of an actual attack on the network than unresponsiveness. You can also see that as the number of offenders increases, that the percentage that you can get slashed also increases. So 3 times offenders divided by the entire set of validators with a minimum of 1% is how much you get slashed if you equivocate. Same basic algorithm, except multiplied by 1/20th or divided by 20, if you will, if you're unresponsive. So is there documentation somewhere for the exact slashing rules? So that, if it is not on the wiki, it is going to be there soon. So just so you know, we recently updated the wiki to use Docusaurus to allow better translation. We also made it look a little bit nicer. So if it is not on the wiki yet, it should be going up sometime this week. Or you can always look at the code, which I realize is kind of a suboptimal answer, but definitely we have this information up there for on the wiki already. If you just search the wiki for slashing, it's going to say this basic information there, although with a little bit more definition about what equivocation is. But for the specific rules, you can look into the code. I don't know. I think there is a slashing module from the Substrate Runtime Module library. If you ping me after this, I can go double check to find the specific place where it's implemented in the code and send that to you. All right, thanks. All right, so I already talked about slashing. I want to get, oops, sorry. So is there a situation in which a validator set is slashed versus a single offending validator? Yes, so if in a single slot, if there's multiple equivocations at the same time, all the validators that are involved in that will get slashed. And in fact, we can see from the algorithm here that as the number of offenders goes up, we increase the percentage. So if we have multiple validators, being unresponsive at the same time or equivocating at the same time, we take this as one of 2 things, right? Either there's an attack on the network, and the larger the number of validators that are involved in the attack, the more serious we consider it. So that's why the percentage is increased, or that there is a set of validators that are not properly decentralized. So for example, if let's say Amazon East goes down, so like one particular data center or data region goes down, and it turns out huge number of our validators were using that data center. We actually want to discourage that. We want to have this as decentralized as possible. So the more decentralized you make it, the more unusual situations you have, different data centers, different locations geographically, et cetera, the more likely when there is a problem that it will just be you and not a whole group of you, and so you'll be slashed less. Yeah, so could someone force a set of validators to be unresponsive? So yeah, there are a variety of ways that this could happen. So if you look at our guide to setting up a secure validator, we actually have a couple of different ways to avoid that. So for example, if you had your validator directly on the network, you are vulnerable to a distributed denial of service attack. However, there are some ways around that. Such as using sentry nodes, basically having multiple nodes that act as kind of firewalls or staging areas onto your validator. So there are ways to avoid this, but that is definitely an attack that is possible. So again, if you look up, there's a guide to setting up a secure validator. We have some ways to help avoid it. But I mean, a true a partition attack or like a DOS attack, both of those are things that you would have to defend against. All right. Any other questions before we move on to how block production? So yeah, so you can signal in an era that you don't want to validate in the next era. So that's a maximum of 4 hours on Kusama. So you can say, hey, all right, I don't want to validate anymore at the end of this era. So hopefully, your hurricane tracking information gives you at least a few hours before the next era starts. So at the end of the current era. So if it happens like, hey, I just realized the hurricane's coming and this era ends in 30 minutes, then you can still submit, and then when the next era comes, you won't be part of the validator set. Yep. All right. Anyone else before we move on to block production? All right. So I already mentioned there's really two aspects of producing blocks in Kusama. Parachains can produce blocks any way that they want. So as long as they follow some rules on how to interact with the relay chain, they could do whatever they want. They could have their own proof of work system. They could have blocks being produced every 5 seconds. They could have blocks being produced every 20 minutes. They could have 10 megabyte blocks. They could have 3 kilobyte blocks. Anything they want to do. The relay chain blocks are produced using a much more established mechanism. Since we are in control of the relay chain, we are not in control of all the parachains. And the whole point is that these parachains can come up with their own ideas of what are the best trade-offs to make for them. Because all of these things, right? Different size blocks, different speed of block production, different proofs, all of these have their own trade-offs. Kusama relay chain blocks are produced about every 8 seconds, and they use 2 mechanisms. So Babe is the block production mechanism, and Grandpa is what's called the finalization gadget. So the difference between production and finalization, if you're familiar with Bitcoin, you've probably seen that blocks can be produced, but they're not really considered finalized, quote unquote, until at least 6 blocks have been produced over the transaction that you are actually interested in. So block production is, a block has been generated, it's been validated, but it may not be canonical. So it may not be the one that actually gets entered into the blockchain for all time. Again, we see this on Bitcoin. It's rare nowadays, but you saw it much more in the early years, where multiple blocks were produced, and depending on when in the network different systems got them, different servers got them, different nodes got them, they would have to pick one or the other. So you had this sort of temporary fork. You see this a little bit more in Ethereum with Uncle blocks being produced because it has a much faster block time. So a block could be produced, but it may not end up in the blockchain eventually, as time goes forward. So there's also this concept of finalization, where a block is now, it's a canonical part of the blockchain. It cannot be removed. We've determined that it is here for good. Again, in Bitcoin, generally what we say is that it should be 6 blocks produced on top of it. But we actually have our own finalization gadget in Polkadot to create provable finality. Yes, that is true. I was about to mention that. Thank you. So as Terry was kind enough to mention, we say that we should have 6 blocks on top of it, but that doesn't mean that it is definitely you have proven beyond a shadow of a doubt that it is now a canonical part of the blockchain. It's just a sort of rule of thumb that it is very, 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 very unlikely that a reorg would occur after this, because the amount of work necessary would be so dramatic. So this is called probabilistic finality. You're never 100% sure that your chain is correct. It could be that there is some, magical ASIC out there that is 1,000,000 times as powerful as anything else out on the market, and it causes a reorg of the chain back, 100 blocks. Provable finality is you can be certain your chain is canonical. But the problem with provable finality, there's always a risk of stalling, that is, blocks not being finalized. Probabilistic finality, you can always produce more blocks. You're just never 100% sure that the chain is correct. So the dilemma that we with this is that we want blocks to be able to be produced. We don't want to stall, but we also want to have true finality, like provable finality. And so what we do in Kusama is we have two different algorithms. So we have Babe for producing blocks, and a second algorithm, Grandpa, which finalizes blocks. So Babe is blind assignment for blockchain extension. So if we think about this, in the beginning of each era, a validator is going to run this VRF, this verifiably random function, and determine, all right, for this, which block should I, which slots, 8-second slots, should I produce a block in? So here I have kind of a quick graph of this. If we have these little person-looking things as validators, and we have slots in the different eras, we run the random function, and I determine that in E1 I should produce something at slot 1 and slot 3, and so I will do that. So instead of using proof of work to determine, all right, when am I going to be able to find a block that I can send out, I use this, again, it's a verifiably random function, and we can prove that people are following the rules for this random function to determine when they're going to actually have a turn to produce a block. So there's also Grandpa, which finalizes it, ghost space recursive ancestor deriving prefix agreement. So again, there's papers on Babe and Grandpa on research.polkadot.network if you'd like to get more deep into the math of how they work and why they work. I want to talk about it at a very high level, because this is not a very, very long discussion today. But the basic concept is 2/3 of all stake bonded to validators agree on the highest block, which will then be considered finalized. So if we see here, we have all of the different nodes 1, 2, and 3, that have agreed that C is the highest block. D2, D1, any of these other blocks that are up here, they haven't had 2/3 agreement yet. So you can see that if all of these nodes 1, 2, and 3, their total stake out of 100 is 75. So if they all agree on A, B, and C, that's 75% of the total stake, and so this is considered a finalized chain. D1 only has 20% of the total stake. D2 has 55%, which is a majority, but not the 2/3 majority, supermajority needed to finalize. So if the other $25 or 25% of the stake came in and decided that D2 was also the highest valid block, well, now D2 is going to be finalized, whereas this D1 over with node 1, that is no longer going to be finalized, and node 1 is going to have to say, well, I made a mistake here in putting my stake behind D1, and I guess I have to move over to D2. So the nice thing about this hybrid system is that Babe can keep generating blocks no matter how many validators are active. So if a bunch go offline or there's some sort of problem, we can keep moving forward. We won't have to worry about stalling. We can always move forward. Grandpa, which needs 2/3 of bonded stake, operates, we can think of it as sort of running behind and finalizing the blocks that have already been produced. Empirically, we generally see that finalized nodes are close to chain tip. That is the last Babe produced block. Usually within a few seconds, we'll see Grandpa finalizing the block behind it so far in Kusama. We see similar things with the other test nets that we ran, including Alexander. If anyone's looking at Kusama right now, which in case you don't know how to do that, thank you. If you go to polkadot.js.org, apps #explorer. So we can see, again, this is Kusama, expect chaos. We can see that there was a stall here. So we see that Grandpa stalled at 58,822 blocks. However, just because Grandpa is stalled, and we can still continue on producing blocks here, they're just not finalized yet. All right, so that's the basics of how validators produce blocks. So I want to move on. The last major section here I want to discuss about Kusama is governance. So the interesting thing about Kusama and Polkadot is that Kusama node is not running the network directly. Instead, it's running a WebAssembly blob of bytecode, which is modifiable by the system. The cool thing about this is that we can actually modify the relay chain on chain. So we can use governance mechanisms of the chain to actually update the chain itself. I'll answer this question. So why this stall and start finalizing again? I'm not sure. I saw it right before I'm not sure why it's happening right now. In the past, what we have seen is like if we had some so I'm not sure why it's happening right now. I just noticed it. You can see it just happened recently. But in the past, what we've seen is like if enough validators drop off so that we don't have enough stake for it to finalize, then that could be an issue. And so it can't finalize. Not enough stake is online. The other reason is if there's some sort of bug, or if there's partition occurs. There's a variety of reasons it could happen. I don't know why it's happening right now. Yeah, so governance. So we have a couple of goals when we're trying to govern a blockchain. We want to make sure that we can make good decisions. That the people that own Kusama tokens will be able to do what they want. We're not going to have the tyranny of the minority. However, we know based on other blockchains that there's often limited voter attention. That is, not a huge percentage of voters will actually show up to vote on everything. So we want to make sure that even if a small number of people vote, small amount of stake votes, that we still have good results. We want to make sure, we want to try to avoid forks. We want to try to keep the community united and realize that what we're doing and have a way of showing that there is a majority of people that actually agree with this. We want to make sure that we don't have certain parties that are privileged over others. We want to make sure to avoid loopholes. So we want to have things be secure. Again, we've had researchers, if you look at our governance, try to help make sure that we don't have any loopholes in our system, and allow many participants to consider many proposals. We don't want to have a log jam, right, when we have multiple people trying to make proposals. So we do have a sort of executive, so we do have 3 parts to governance. The first and largest part is the referendum chamber, which consists of everybody who holds Kusama tokens. So you're kind of like the legislative chamber. You get to be a senator or a representative or a member of parliament simply by holding Kusama tokens. You are able to vote on anything. There's also a council, which is elected by the Kusama holders. And this is sort of a way to represent the passive holders of tokens who may not be there voting on every single item. And finally, there's a technical committee, which allows, to get on this, you can implement a runtime or a runtime environment, and the council will allow you to join the technical committee. So the technical committee has a very restricted membership, and they also have a kind of restricted abilities. So what they can do is really just fast track legislation that will still have to be approved by the referendum chamber. So the council, and again, this information, like the number of members, is modifiable by governance. So we actually could have a governance proposal to increase the size of the council or decrease it. It's elected by stake on a rotating basis. So what this means is that basically every period, about once a month, you will get to vote on a new council member. The technical council. Again, teams are added or removed by the council. And if you develop a Polkadot runtime environment implementation or whatever the current Polkadot runtime is, then you get to be on the technical council. It is possible for a team to have multiple votes. So for example, if you develop both the runtime environment and the current running runtime, or if you create a Polkadot runtime environment in language A and language B, you may have multiple votes on the council. So you may have the same entity with multiple votes. So the core aspect here, what all these different parts of the governance can do, is basically vote yes or no on referenda. So a referendum allows you to vote on modifying the chain code itself. So a referendum contains a proposal to do something, and it's binary. You can only say yes or no. You can't say that, well, I want to do 2/3 X. It's, if a referendum is voted on, it's either yes or no. Or theoretically, you could abstain. You could just not vote if you want. Some sample proposals, things you could vote on, like modifying the balance of an account. So if there was, tokens that were stolen and the people agree that this person should be made whole, or we should increase the amount in the treasury or something like that, we could vote on modifying the balance of an account. We can register or deregister parachains on the relay chain. Modify the blockchain parameters. So if we determine that these slashing penalties, that somebody asked about earlier, are too restrictive, we actually can modify those. Or if we have issues with the block generation time. So one thing that was fun when I was messing around locally was setting block generation time to some incredibly small amount, like multiple new blocks per second, which causes some issues as the system can't really keep up with it. So we may determine as we get a larger number of validators, oh, maybe we should have a slightly longer block generation time. Or we may figure out that, we can make it a little bit shorter without any difficulties, but we can vote on that. We can vote on funding projects from the treasury. We can even cancel other referenda or update the Polkadot runtime code itself. So the Kusama code that is running this WebAssembly blob, we can actually modify it and update it. And this is actually something we've already done on Kusama and something that we will be doing when we move to proof of stake. So we won't even have to send out a new version of the software. We'll be able to update it online by modifying the runtime code. The ultimate power is always going to rest in the hands of Kusama holders, though. So the council or the technical committee, none of these people can directly bring anything into being. They can only propose referenda. So the Kusama holders will simply have to vote on them. However, if the council has an unanimous support behind a proposal, it's going to be easier for it to pass. So basically, we err on the side of passing for proposals that the council has passed unanimously. If the council does not agree unanimously, then there can be it's basically a majority rules. And if Kusama holders propose something, then you actually it's biased towards not passing. So again, if a majority of people vote for it, then it will in fact pass. However, if only a very small number of people vote for it, it's biased towards failure. So what this means is if you, let's say you have you're an unscrupulous Kusama holder, and you put in a proposal to give yourself 1 million Kusama tokens. And you happen to do this in August, and everybody's on vacation and no one really notices it. And so only you and you say you have 1% of the Kusama tokens, and only a few other people notice it. So, half a percentage vote against it, and 1%, your percent votes for it. Well, we don't want that to pass. And so the smaller the number of people voting for a public proposal, the smaller amount of stake rather, voting for a public proposal, the harder it is to pass. The percentage is actually, you're gonna need more of a supermajority. However, if 100% of the Kusama holders vote on something, then it's always going to be 50% plus 1 passes, a simple majority. So there are a couple of other wrinkles to Kusama governance, but all of them are made for trying to make it as fair as possible. So what is the future? Again, Kusama is not a test net. It's going to live on as long as people find it useful. Once we basically take the chains off and move to proof of stake, which again should be happening in the very, very near future. Web3 Foundation, Parity, the people that have the community that has put it together so far will have no control over the network. And we anticipate Kusama being kind of a mix between a test net and a main net. We see people using it as a test bed, especially in the earlier days, but also perhaps using it for people that don't need the perhaps more expensive interaction with the Polkadot mainnet. They may continue to just use their project on Kusama. If you would like to obtain Kusama tokens, there are a couple of ways to do this. First off, if you own DOTs, you can claim an equivalent number of KSM tokens, Kusama tokens. So if you go to claim.kusama.network, you can see how to claim there if you already own DOTs. We have a frictional proof of work faucet. So basically you will have to generate a vanity address with KSMA as part of the address. And we have tools for that, but it will use your computer to do basically, proof of work on your own system. So we don't have people just grabbing more and more tokens. It will actually require some computational work in order to do that. The Web3 Foundation has set aside 1% of all Kusama tokens for grants. So if you do have something interesting that you would like to work on in Kusama, but you need some Kusama tokens to do it, if you go to grants.web3.foundation, you can see the form for applying for grants from these. Just like any other token, you can obtain it from others. So if anyone has tokens and they would like to give them to you, maybe in return for something, then you can obtain them from them. And finally, we do have a bug bounty program. So if you do find a bug, then we can, and if you responsibly disclose it to us, you can receive Kusama tokens in exchange for reporting that bug. If you'd like to stay up to date on Kusama, I have a couple of links here. We do have a newsletter that goes out on a regular basis. You can sign up for a Kusama.network newsletter. Our homepage is at Kusama.network, at Kusama Network on Twitter. We have a user guide linked to from guide.kusama.network. And I see a few familiar IDs from our Riot chat. So if you go to that room, that is the Kusama water cooler, which is where there are always people that are working on Kusama and willing to help you out and try to get you up and running. If you have questions for me, I don't know if I didn't put my information on here, but my name is Bill Laboon. If you email me, it's bill@web3.foundation. Then I'm, or just chat. If you see me on the water cooler, I'm Bill W3F. I'm happy to answer any questions you have there. Or if you have any questions now, just put them in the chat and I will answer them. Oh, I already see. I didn't get a chance to finish. Okay. Is there a link to the PowerPoint? So I can put a link to the PowerPoint. I will put it up right after this. And I'll put a link, where would be the best way to share it with everyone? I can put it in the water cooler if you like. That's probably a good place for it. Do parachain project have to use Kusama parachain slot versus Polkadot parachain? So no, you could have you could develop a parachain, and you should be able to pretty seamlessly put it both in Kusama and Polkadot. Now there may be some minor changes between the Kusama version of the code and the Polkadot version of the code, but they should be pretty minor. We have, again, Kusama is meant to be an early release. It's meant to be the same basic idea. There's just, the same API and everything. But there are always, whenever you're working with software, there's minor things that go wrong. So you could have a version of your parachain running on Kusama and a separate version running on Polkadot. Theoretically, you also could use a bridge between the Polkadot relay chain and the Kusama relay chain. So you could have something between, communicate between Kusama and Polkadot, but I don't know if anyone is actually working on that. Same chain or same code? That'd be the same code. So to run the exact same chain, you would need some sort of bridge between the two. So that's something you could do, but having them run, having something on Kusama and Polkadot that's the exact same chain, that would require some extra work. But using the same code should be pretty simple. You just have a Polkadot version and a Kusama version. Any other questions? Will governance council slots differ on each chain initially? So if that, so I don't think we have a finalized version of what the number of council slots will be on Polkadot right now. So they may differ. There's certainly nothing stopping them from differing. Again, since all this is modifiable by governance, we could see, for example, Kusama may be a smaller group, and so the number of council slots gets smaller as people choose via governance, and maybe Polkadot gets larger. There's nothing, connecting the two that would make them stay the same. As for initial, I don't think we have a number set yet for Polkadot launch. Again, just somewhere between 6 and 24 initially. Are there limitations to the amount of parathreads per parathread slot? Not specific limitations. I mean, at some point you would have so many parathreads that you would have the equivalent of starvation, where one parathread may not get in enough times. I don't think there are any specific laid out limitations at this point. Because you could have a parathread or a parachain basically stop being a parathread. It was applying to a slot and then decides that, hey, I don't need to do it, or I don't need to do it for a long time, and so it just doesn't take doesn't take part in auctions. So there's no that parachain then could decide it wants to be a parathread again in the future, and it applies for that auction again. So there's no built-in limitations. You may see again a sort of de facto limitations that even though we don't have something built in, just people don't end up using it because this particular slot doesn't, they never have a chance to get in. However, what we can do is also create more than one slot for a parathread. So I think that the council, if they see that there is this overloading on a particular parathread slot, that they'd be able to convert or either create a new slot for parathreads, or convert something that was set aside for a parachain and make it another parathread slot. All right, so what are hardware requirements looking like? So we actually had some numbers for that. I don't have off the top of my head. I could look up for you. Basically a good home computer. Definitely not. I think doing something like a Raspberry Pi would be may not be possible. But you certainly shouldn't need like an extremely powerful rig. Like a mid-range server on DigitalOcean or something like that. And again, we have numbers. They're on the wiki somewhere. I just don't have that information right off the top of my head. I have to do some searching. But Federico, our DevOps guy, has actually done some tests on that. So if you send me an email, I can actually give you send out a link and show you what it looks like with some different parameters and some different assumptions. If one parachain has smart contracts, can it become a parathread? Sure. There's nothing stopping, if a parachain has smart contracts, those smart contracts can run entirely on that parachain. And just whenever it reconnects to the relay chain, then it updates all what state has transitioned since then. So definitely parachains acting as parathreads can have smart contracts on them. Any other questions? Okay, well, if anyone does think of anything, again, please feel free to email me. I am bill@web3.foundation. I'll type it in here just so you all have it. Or I'm happy to talk to anyone on the Riot channels. Yeah, thank you all for coming. I really appreciate it.